assignment which was given in Masterclass 1, which was basically Anaconda software. Then in the last masterclass, you were given a set data set to analyze, and all the tasks were mentioned in your chat box and in the WhatsApp group. I hope you were able to do it. So today you will be provided with the third assignment. You have to be very careful to how to go about the assignment. Make sure that you note all the points because we will be closing the submission soon. And as usual, do not forget to fill in your attendance before you log out of the session. Okay. I hope, because we've been repeating this quite often, that learning plan submission certificate, I hope you already have submitted in the links that has been shared in your WhatsApp group. Also, I know we have these masterclass here, but do not forget to keep a watch on your WhatsApp groups because all your data sets, all your links, all your forms will be shared there. Okay. So that was from me. Now I will hand it over to Karthik. So Karthik, we have one query that the car's data file, which was uploaded in group, has inappropriate characters. We could not access the data in it. So somebody has asked this. Can you please address this?
As data, there is an
Inappropriate characters that they
oh,
could not access. You're saying.
okay. Okay, so maybe I can do one thing. I just realized now in the file, in the last line of the Excel file which I had shared, there is some text of saying that showing 1 to 17 of 32 entries and all. You can probably just delete that and save the file and then, just do that again. Let me just share my screen quickly and probably take it up. Okay. So just let me know you're able to see my screen. Okay. Okay, perfect. Okay, great. So, sorry, I just realized one thing. Okay. I just saw that there is this thing over here in the end. Just delete it like this and just save it once again. Okay, that should do the job. I didn't realize that that line had come up in the file. Okay, I think then you should be able to read the file. Okay. Any other question, guys, from the last session? I have 32-bit laptop, not able to install Anaconda. 32-bit, huh? Okay. Uh, 32-bit. You can just check Misha online to download it. I don't know. Anaconda nowadays, no 32-bit is very less. So we'll have to check once. Just let me check once, okay? Give me a second. Most of the time it is 64 only. But let me see if there is anything on that. Yeah, looks like they have only 64-bit. Let's see if any of the old ones they have anything. Hmm, Old installers. Send packages. The thing is not 32-bit now. Most of the systems are 64-bit, right? So that's why these guys may not be keeping much on that, I guess. Okay, looks like it's not there. Okay. Hmm, what can we do for you? Let me do one thing. Okay, I'll probably just check, and after this session, right, I will see if there is any alternative which we can use to install that. Okay. See, worst case scenario, if there's nothing, you can use the online Google Colab for yourself. Okay, Google Colab is there, right? You can use Google Colab for your development because that's exactly like a Jupyter notebook. Okay, just for your reference, I am putting the name also again here in the chat. It is called Google Colab, COLAB. Okay, I'm just putting it in the chat. So you can use this. Okay. So that way it will become a little bit easy for you to avoid that issue of 32-bit. Okay, because it is browser based. Okay. Okay. I'm just trying to catch up on the chat. Okay. Uh, And some, yeah, I think one more issue was that, reading the file, there was an encoding issue. I think you can use that Latin. We had shared it in the chat also, right, to read the file. So people probably who have written that reading part, right, with encoding equal to Latin 1 or Unicode that, can you just put it in the chat to everyone? It would be good, helpful for everyone. Okay, can you tell if VS Code is fine? Yes, yes, please go ahead. I have already mentioned earlier also, right? VS Code, PyCharm, Google Colab, Spider, whatever you want. Feel free to use anything as long as you are comfortable using it. But I not only myself, it's most of the people in the industry also, right? They tend to use a lot of Jupyter notebooks for development work, experimentation phase. Okay, so I think it's very common to use. Not able to open the file in Jupyter. Yeah, I think it's mostly the encoding issue. Just use that piece of code which I'll have someone put it. Okay. Yeah, if there is anything available online, you can use that also. Yeah, I think some few of them have shared a 32-bit download version. Let me put it for everyone maybe. Okay, let me see. First, let me check that. Okay. This thing is. Uh, Okay, Anaconda 32-bit Windows 7. Okay, I think there is someone who has shared this. I think just see if it helps you all out. Yeah, and I think Srishti has. Okay, wait. I think this has gone only to me. Let me paste it for everyone. Okay, people who are facing issues with reading file, right? I have put the line of code which you may want to do it. Okay, sometimes there is some encoding issues that come up because of differences in the machine and file and all. Okay. Okay, so I think let me take up. I'm just looking all the. Okay, there are a lot of questions which have come up. Just I'm trying to go through one by one and come up with a answer for each one of you all. Encoding issue, information about PPT work. Okay, so information about PPT work. What I'll do is at the end of the session, I'll give you a idea of how you want to put the output and share it across. Okay, so that you can also have an idea of what would be the best way to present it. Okay, okay, included due to this need to pass. Could not understand 25 and 75%. Yes, I will take it up. Okay. I just wanted you all to go through that just for your understanding purpose. But don't worry, I'll also talk about it a little bit. Assignments, please put it in a PPT. Okay, PPT would be easier. I mean, it looks much better also, right? Put it in a PPT, write your analysis, your interpretation in the PPT itself. Okay. Yeah, yeah, please. Yeah, I think there's a question like in the first assignment was the installation. So if that is not there, we can use Google Colab. Yeah, it's fine. It's fine. Okay, you can use Google Colab as long as the goal is the part of that assignment's goal was that you should be able to use the environment. That is the goal. It need not necessarily be the Anaconda on your local machine as long as you are comfortable with Google Colab or you are comfortable with VS Code. You need to be sure that you're able to start using the environment. That is what matters. Assignment related topic, I'll take it up. Okay. I'll talk about it in the discussion now. We do the assignment of masterclass 2 assessment. Okay. Looks like lot of questions are around the assignment part. I think we'll do one thing at the end of the session. We'll quickly take up an idea of how to show the output and analyze things. Okay,
Yeah.
we'll do that so that you have an idea.
Yes, Karthik, before you start the class, I just have a little announcement to make.
Yeah, please
So
go.
we have a few people joining us on YouTube Live. I would request you all to join us here on Zoom for an interactive experience. You'll be able to ask questions, you'll be able to interact here. So kindly please join us here. And as Karthik mentioned, we'll keep a short Q&A at the end of the session. Okay. So we can begin with the class now. All the best, learners. Yeah. Thank you.
Perfect.
Karthik, the floor
Yeah.
is yours.
Thank you, Tamza. Thank you. Okay. So, guys, what we'll do is we'll quickly, have a recap of what we did in the last session. I'm not going to get into the nitty-gritty of that, but quick touch base on what we have discussed so far. Okay, and we'll then move to the next topic. So, if you remember, in the previous session, we discussed about how to start using an account. I mean, how to start using Jupyter notebooks, how to start a notebook, how to start editing the notebook. Right? We learned all those things, and then we started playing around with the notebook in creating objects, right? As I told you, objects are nothing but anything you create in Python is an object. Okay, and see, you know, I'll tell many people this part of a discussion, right? See, programming is a necessity, okay, and you are right now in the probably there are many of you who already know programming very well, and there are many of you all who are probably just beginning the journey of learning programming and all. So don't get overwhelmed. There are many programming languages outside which people will tell you learn this, learn that. But start off with one particular programming. Probably Python is the best thing to start off, because most industries or most development work, many organizations use Python. Okay. Coming to programming itself, right? Don't get again overwhelmed with the number of things that are there in it. You need to take a step by step approach and slowly learn it. Okay, it will take some time for you. And third thing is, what I am teaching is probably I'm giving you an idea or overview, but there may be a necessity for you to go in depth of it over the next period. Okay, maybe you all want to take it up further and learn more, right? You all may want to do that. I'm giving you an idea right now. Okay, so that is why, right, when I'm talking about certain technical terms like object, class, function, methods and all, right, these are very deep topics. Okay, you have a lot of things to discuss in that to know it better, but I've given you a very high level view of what it is. Okay, there's a question: Python language is sufficient for data analyst? See, um, data science as such, right, is a way is has lot of things involved in it. You need to know lot of tools and technology to learn that. Okay, it will take some time, but Python is a good start. Okay, and I that's why I told in the one of the initial session also, I told you, all right, there are different lines or different lanes you can take based on your interest. Okay, so there is you can go into the data engineering, data visualization, data analyst, machine learning engineer, ML ops engineer. There are many lines. Okay, so you can take any one line which you are interested in and go further. But knowing a programming language is always going to be a good start. So Python is good to start off with. Okay, but always remember, it's always good to have a primary and secondary programming language in your skill set. Okay, I generally recommend Python as one and R as one if you're going into analytics. Okay, because there are, if you're going in another line of work, like if you go in data visualization, then you may want to learn tools like Tableau, Power BI, and all such things. Okay. Now, so coming back to our discussion, okay, coming back to our discussion, okay, there's another question. I'll quickly take that. As they were told, there are many ways how we can find which path is right for us. Okay, so the thing is, no, based on your interest. For example, you find programming is something you're struggling with, right? Then probably visualization is something you can think of, because visualization, you need to have an analytical mindset. Okay, that thinking should be there. If you have that, I think you can do pretty well in this field. But if you are having a struggle with programming, you're finding it very difficult, right? Then I think visualization is a good idea to look at. Visualization is, as another field, has a very good scope to grow. Okay. But if you are already on the technology side and you have good grasp on programming and all, I think this line of development work, becoming a machine learning engineer or a data scientist becomes kind of easier for you. Okay, so yeah, I see some questions regarding opening file and all. We'll see that. Okay, we'll see that part. Is Python IPy kernel and Python Conda environment base same? Yeah, don't get confused with all those things. As of now, just stick to what I am telling. Okay, there are a lot of other things. You can create virtual environments and all those things. Okay, so don't worry about those as of now. Just go with what is there in the Jupyter notebook. Okay, so coming back to our discussion here, we discussed about objects, right? What we are looking at is anything that you create in Python is an object. So basically, why are we creating objects is that you can save things inside that and use it in future. Like, anywhere down the code, you may want to use it. That is why you're doing that. Okay, so like that, we saw how to create objects, and then we realized one important thing about case sensitivity, right? Small letters and capital letters are completely considered as different in Python. So you need to be very careful about creating objects. Try to stick to one case. Okay, so either small letter or capital letter, try to stick to that. There's nothing wrong. You can mix them up as long as you remember to use that properly again. Then not only numbers, you can also store text, but when you're storing text, you need to put them in quotes, either single quotes or double quote. Any one of them you can do. Then I also told you all about creating object names. You cannot start with a number. It has to always be an alphabet. After that, it can be anything. It can be an alphabet, can be a number or anything. It doesn't matter. So you need to start with an alphabet. Okay. Now, then we saw that you can also do mathematical operations in Python, right? So you can keep two numbers in two objects. Then you can try to add them, subtract them, divide them, multiply them. Then we also discussed about function, right? I told you functions are like in Excel, you have functions, right? Just like that in Python also you have functions. In this, we used one function called print. What does print do? It prints the value which is coming as an output from the calculation. So that is what we did over here. We were able to print it. Then we discussed about one concept called library. What was library? Library is nothing but, I told you already, this is an open source community. So people are contributing to this project. So uh, what happens is the best part of having an open source community and making use of it is um, you don't have to do things from scratch. Someone like you has already had some problem what you are looking at, and that guy or that community or person or individual has been kind enough to contribute it back to the community. Okay, and actually it would be also great if in future you all also can start contributing. That adds a big value to your your career also when you start working, right? It is a big thing to have under your name that you have contributed for a particular library. Okay, it's a big deal. So these packages are or libraries are nothing but there are a set of functions. There are a lot of functions people have written and given it so that you don't have to do things from scratch. Okay. So what we do is we take that package and install it whenever required based on our requirement. So how do we install? Exclamation mark pip install package name. Now, common question that comes to me is how do we know which library to get or use, right? See, that's the tricky part. There is no, there's no direct way to do that. You have to search online saying that what is your problem, and probably somewhere in the discussions, right? Someone will tell you this package has this function, use it. Okay, so then you install that package and start using it. but you have to search. Okay, so that's the only way we have to find out what libraries are available for us. So once you install this, this is a one-time job. Okay, you don't have to do this again and again. It is just one time. One time means when you don't have it on your machine, you're pulling that and putting it on your machine. After that, you don't have to do it. But every time when you close your notebook and open your notebook, okay, you need to use this import function name. Okay, you need to use this import function name. So what you will, sorry, a library name, not function name, library name. Okay, so what we need to do is you just say import and then the library name. It will show you this. Okay. And then I also told you all about if you need any help on any particular package and a function. See, think of it like this, okay? A package is like a zip file, okay? Inside that zip file, you have several functions. So whenever you want to access any function, you need to write the package name dot the function name. So this is the format in which you have to give, okay? You say the package name dot the function name. And then what you can do is you can just pass the input and it will give you the output. Okay. So this is how you can use the libraries. Then we started talking about data analysis, right? So we were looking at how do you analyze the data, right? So that is where we started talking about some of the statistical measures which are there for us to analyze the data, right? And for using that, we thought we will use the pandas library. Pandas library is a very famous library for all data related activities. So you can make use of pandas. And this may not be there directly in your this thing. So you may want to do a pip install of pandas. Once you do the pip install, what we do is you import that package or import that library. I may use this terminology, I may swap them and use, okay, library and package. So you can understand that it means library. And what we do is we give an alias to it. Alias means like a short name for it. Instead of saying pandas, pandas, pandas everywhere, we are going to use the short name as PD. Okay, you can give any name, nothing, there is no hard and fast rule that you should use PD. You can use just P, you can use A, B, BC, anything you can use. There's no problem in that. Okay, so after this, what you do is you read the file, you read your data set. Our data set is in a CSV format, right? So this was the file I had shown you all, right? So this was the file. So this file, we are reading it inside our Python. See, what is happening now, the file is sitting on your laptop, right? It is there on your drive in your machine. Python doesn't know still that there is some file called carseats.csv. So once you read this, what it does, it brings that into its memory and keeps. So now Python knows that, okay, there is an data set called car seats and it will read that and keep that data in its memory. And if you want to see that data, you can use this function called head. So it will show you the first 5 rows of your data. If you want to see the full data also, you can see, but just to see a quick overview of your data, you can use the head function. And then there is this attribute called shape. And if you all remember, I told you last time, right? Whenever you see an open and close bracket, that means it's a function. Whenever there is nothing right now here, we call it an attribute. Okay. Don't worry as of now, that part of it. Okay. Just remember that shape doesn't have an open and close bracket. Again, a question also comes to me is that how do we remember whether to use the bracket or not? I think that's only with practice. Okay, there's again the part where sometimes even I get confused that whether I should put a bracket or not. But now with experience, right, I know that after shape I shouldn't put. Okay, that's more you practice, you'll get used to it. Okay, so what does shape do is shape tells us how many rows and columns are there in my data. It is telling there are 400 rows in my data and 11 columns. So what do we mean? See here, if I count, see here, there are 400 rows in my data. Okay, and if I go like this, see how many columns are there? 11 columns are there. Okay, so this is what is the shape attribute telling us, okay, how many rows and columns are there. Then we discussed about a function called describe. So, whenever you are given a data, you can do this describe function. You can use this describe function and see some statistical measures which can help you understand about that data set, about each variables in the data. This is called univariate analysis. Okay, it is called univariate analysis. Okay, it's called univariate analysis. Now, what does the describe function do? It takes all the variables and prints them over here, and it gives some important metrics that you may find it helpful for you, right? It gives you the count, unique values, top, frequency, mean, standard deviation, minimum 25 percentile, 50 percentile, 75th percentile, and maximum. Now, we discussed about certain features, right? We talked about mean, median, standard deviation, and range. Okay, can you guys tell me what is the difference between mean and median from the discussion we had last time? What is the difference between mean and median? Exactly. Great. Okay. So mean is affected by outliers. Yes, extreme values. But median is not so easily affected by outliers, right? So that is exactly the one important characteristic of mean and median. And now, how do I know if there are outliers in any of the variable? Like, let's say there is this variable sales. How do I know if there are outliers in this data? Exactly. Okay. So your mean and median will be extremely far away. I mean, they will be far away from each other. Yes, it will be too far from the mean or huge difference in mean and median. Okay, correct. So there will be a big difference in mean and median. See, if your mean and median are very close to each other, see, don't expect them to be exactly the same, but if they are close to each other, then it means that they are not having much outliers. But if the mean and median are moving away from each other, that means there are outliers. Okay. So remember that way that you know that there are outliers in your data. And similarly, we spoke about standard deviation and range, right? This tells you how the data is spread. Are they all concentrated close to the mean or are they spread away from the mean? So if the standard deviation is small, it means the data is close to the mean. Most of the data points are close to the mean. If the standard deviation is big, that means the data is spread far from the mean. Okay. So what does that make us understand is, see, for example, let's say if there is a rain forecast and the rain forecast is given that this year we will have a rainfall of 20 centimeters or whatever it is, 20 centimeters. Okay. And now they have told you that it is going to be 20 centimeter and standard deviation is plus or minus 10. Okay. Standard deviation is plus or minus 10. That means what? See, these are all forecast, right? I mean, they are all trying to predict some value, right? You can never get an exact answer. So there will always be kind of an error in it, correct? So what happens is if your standard deviation is high, it gives you too much of scope of thinking what is it going to happen. Is it going to rain or it is not going to rain at all, right? 20 centimeter plus or minus 10 centimeter means it can rain 10 centimeters or it can rain 30 centimeters, right? So when we think of it, it is quite unpredictable in this range. But if I have a smaller standard deviation, that means I'm sure that what this person is telling as a forecast is kind of reliable. Okay. So that way, again, let's take another example. Let's say cricket. Okay. I think we spoke about it in the last session also, right? So let's say there is a batsman who is scoring 50. Okay. His average is 50 and plus or minus 30 is his standard deviation. That means what, he scores somewhere between 20 to 80, right? 50 minus 30, 20. 50 plus 30, 80. So the person is scoring somewhere between 20 to 80. So this right is not very reliable, or this batsman is not very reliable. But at the same time, I have another batsman who scores, whose average is 50 and standard deviation is 10. So that means what, plus or minus 10. So somewhere between 40 to 60. This guy is reliable because he's consistently scoring between this range. Okay, so standard deviation is nothing but it is like an average of the deviations from your center. Okay, actually, if you look at the formula for standard deviation, right, it will look like the formula for mean only. So, what is the formula for mean? We write it like this, right? Summation xi minus, sorry, xi by n. Okay, if I have to write the formula for standard deviation, yeah, square root of variance, right? So if I put it like this, summation xi minus x bar the whole square by n. Okay, let's say if I make this thing equal to y. So if you see, it is what? Summation y I by n, square root of that. Okay, so if you see something now, doesn't this formula look very similar to this? It's very close to that, right? Only that this is deviations. What are these deviations? They are the deviations from the center, right? Let's say there is data like 1, 2, 3, 4, 5. So mean is 3, right? Mean is 3. What is this doing? We are calculating the difference of this value minus this value minus this value minus this. Oh, sorry, is my board not visible? Okay, let me share again, okay? I'm not sure. I'm sharing my entire screen, so hopefully it should be visible now. Ah, okay, it's visible. Okay. Oh, okay. Okay, great. Okay. Someone said that, it's not visible, so I thought maybe I've shared only one particular screen. Okay, perfect. Okay, so what I was saying is, what is standard deviation talking about is standard deviation is nothing but it is taking the differences from the mean, right? So this value minus the center, this value minus the center, this value minus the center, this value minus the center. And then you're taking the average of that. So what is standard deviation? Standard deviation is nothing but the average of your differences. Okay, it is the average of your differences. See, if I see here, what is the difference? Minus 2, minus 1, 0, 1, 2. Okay, actually, why are we squaring it? If we don't square, right, and you add this up, right? If you don't square it and you add this up, what will happen? See, minus 2 plus 2 cancelled, minus 1 plus 1 cancelled. So answer will become 0. So to avoid that kind of yeah, exactly, it will cancel it off. So to avoid that situation, what we do? We square them. Exactly. Right? So we square it to remove that sign. So what happens? Minus 2 becomes 4. Minus 1 becomes 1. 0, 1, 4. And then you add it up. And that is the reason why you take a square root, because this is some, so you are introducing this into the formula and now you want to remove it off, right? This is something you did to avoid this problem. You did the squaring to avoid this problem of summation becoming 0. Ideally, we are not supposed to do that. But now what we want to do, we want to bring it back on the original scale. That is why you're doing a square root of it so that you cancel off these two in the finally. Okay, so the point is, I want you all to understand that standard deviation is nothing but it is the average of the deviations from the center. So when I'm saying standard deviation is equal to 10, it means on an average, the deviations are 10. Okay, average deviation is 10. So that is why when I'm saying one batsman scores average 50 runs and standard deviation is, standard deviation is 10, it means, you are telling that it is somewhere between 50 plus or minus 10. So somewhere between 40 to 60. Okay, so average is in the middle, 50. So it ranges between 40 to 60. So smaller the standard deviation, better it is. Higher the standard deviation, that's not such a good situation. But remember one important thing in this, the scale, the scale of the variable, the standard deviation is on the scale of the variable. What do I mean by that? See, when you are saying here standard deviation is 10, see what is 50? 50 is runs. Okay, here what is 10? 10 runs. Okay, now here this is still okay, correct? So what I'm trying to make you all understand is that the scale of your standard deviation is on the scale of the variable. I mean the unit. Okay, whatever is the unit of that variable, that is the same thing applicable to your standard deviation. Let me give you an example. Okay, see, let's say there is age. Age is in years, right? So let's say you have age and you have 55, 27, 18, 5, 32, like that you have age. Let's say the average age is something around 35 and standard deviation is let's say 20. Okay, let's say standard deviation is 20. So basically you're saying average age is 35 years, standard deviation is 20 years. That means your data is having big standard deviation. Okay, it's having a big standard deviation. Now, let's take the same scenario with income. So income, let's say you have 9,000, 10,000, 6,000, 15,000, like this you have values. So when you take the average income, let's say it is 10,000. Okay, it is 10,000. And now when I say standard deviation is 100, okay, now you may say, okay, 100 means it's bad, right? 100 is a very big number. So you may say that it is bad. But it is on the scale of your currency, right? So this is rupees and this is also rupees. Having a deviation of 100 rupees is actually not a big deal. It is a very good thing. Your deviation is very less compared to that unit. But at the same time, let's say you had a standard deviation of 6,000. That is bad. Okay, that is bad because on the unit of your on the scale of your variable, 6,000 is a pretty big number for your income, right? Having a deviation of 6,000 means the range of your income is somewhere between 4K to 16K. That's again very big range. But if it was 100, it would have been what? 9,900 to 10,100. You see, that range is very small. Okay, so remember, don't just go by the number that you see for standard deviation. Remember what is the unit. Based on the unit, you need to say what is big and what is small. Okay, so that's one thing I wanted to make it clear for you all. Okay, so then we discussed about, so when we discussed about this part, I told you 50 percentile is nothing but your median. So you guys were able to tell me, right, mean and median difference and all. And I had asked you all to see for 25 and 75, but I think some of you must have not got a chance or must have not understood it. So let me give you a idea. Yeah, quartiles, correct. Okay, so uh, see, these are known as your quartiles. Okay, yeah, quartile. Okay, so let's say this is the minimum, this is the maximum. Correct, yes. So this is known as Q1 and this is known as Q3 and this is your Q2. Yes, yes, right. Okay, I think some of you all have got the hang of it, right? Okay, so 25 percentile is how much data lies below your 25th percentile of your data. So Q1 is your 25th percentile, Q2 is your 50th percentile, and Q3 is your 75th percentile. So what do we mean by this percentiles? These are also known as quartiles. Okay, they'll use multiple names. Okay, quartiles, quantiles, percentiles. They'll use many names. Okay, don't bother. It means the same thing. This is your median. Okay, so now what do these quartiles tell us exactly, right? So what we can understand from these quartiles is, I'll take the example of age, okay, because it is easy for us to connect with that and understand what the data is telling us. So let's say I have the data of age. I collected, let's say, 100 people's age. Okay. Let's say you're staying in one city. Let's say you're staying in Mumbai. What you did is you stood in the railway station and you asked 100 people what is their age. And that data you have collected. Okay. So age is there. One person tells 28 years, another person 32 years, another person 50 years. Like that, you have collected 100 people's age. Now, what can you analyze about this data that you have collected, right? So first thing is you guys told me, right? Mean, median we can take, right? So median is nothing but my 50th percentile. So let's say the median of your data is, let's say 35 years. Okay. Let's say 35 years. So what would we understand from this is the median age of this particular group is 35 years. So mostly middle age group, okay, and young working class group. And these people are like, in the early 30s, right? Most of the data is in early 30s. The center point is 35. What is this? This is nothing but my minimum and this is my maximum. What is minimum and maximum? What was the minimum age in this data? Let's say the minimum age in this data was some kid you got hold of who was 10 years old. Okay. And then you also got hold of one person to ask the age who was, let's say, 62 years old. So the minimum age in your data was 10 years, a kid was there, and then there was an elderly person of 62 years old. And in this, the majority of the people whom you asked are around 35 years old. So what do we understand? Majority of the people whom you asked are all young people, right? Now, what is Q1 and Q3? Okay, what is Q1 is? Q1 is nothing but my 25th percentile. So what is 25th percentile? Let's say 25th percentile is 25 years. Okay, let's keep it as 28 to avoid confusion between this 25 and that. So what we are saying with this is that 25% of your data lies below 28 years of age. What do you mean by 25% of your data? That means out of the 100 records, if you take 25% of that, what is that? 25 records. So 25 records or 25 people fall below the age of 28. That is what your 25th percentile means. Okay. It is telling that 25 people in the data set are below the age group of 28. Okay. So can you tell me how many people are above 28 years of age? How many people are there who are above 28 years of age? Exactly. Correct? 75 people. Right? See, 100 people are there. Out of that, 25 people over here are in this age. Naturally, the remaining 75 people are about 28 years of age. Okay. Now, on the similar lines, we have another one called Q3, which is your 75th percentile. And let's say this one turns out to be 53 years. Okay. So now 53 years age means you're saying that 75% of your data lies below 53 years of age. That means 75 people whom you had collected the age are below 53 years of age. Okay. So actually let's get this one part. Okay. I'll just change it a little bit. I'll make this maybe 40, 43. Okay. So I'm just changing it to give an example. Instead of 53, 43. Okay, Aishwarya, just give me a minute, okay? I'll probably unmute you. 1 minute. So let's say the Q3 is 43 years. So we are saying that 75 people whom of this data are below 43 years of age. Now you notice another thing. There are 25 people who are above 43 years of age. Okay, there are 25 people who are above 43 years of age. So you can see that majority chunk of your data are all on the younger side. Most of them are on the younger side. There are only very few people who are on the aged side. Okay, who are a little bit on the elder. So looks like when you did the review, or when you collected this data, most of the people whom you encountered were all young people. So that is what your data is telling, that most of the people in this data are young people. Very few people are slightly on the aged side. Okay. So that is what your Q1, Q2, Q3, all these quartiles give you an idea. They tell how my data is distributed. You get an idea from that. Okay. All right. Okay. 1 minute. So, okay. I see the hand is down. Maybe. Okay. All right. So let's go back. Okay. Now this is what is called your Q1, Q2, and Q3. Okay. So this is your Q2. Now here there is something interesting here now. Okay. There is something called as interquartile range. Anyone who know what is interquartile range? Who have heard about it? Who have seen what is the formula? You know, if you can tell me the formula. Or it is also known as IQR. Exactly. Okay, great. So it is nothing but your Q3 minus Q1. So it is nothing but your 75th percentile minus your 25th percentile. Actually, if you see this IQR, right, it looks very much similar to your formula of range. What does range do? It takes the maximum minus minimum, right? It is like another version of your standard deviation, right? One quick version of standard deviation. So similarly, interquartile range, if you see, it is the difference between your Q3 and your Q1. And what is this actually? It is nothing but if you do 75 minus 25, basically 50% of your data lies between 28 to 43 years of age. See, what is this? 28 years, 43 years. So what you're telling? 50% of your data lies between Q1 and Q3. Okay. What is IQR? IQR is nothing but it is like a standard deviation, but only of the center 50% of your data. Instead of how range is looking at this minimum and maximum, right? Instead, interquartile range is looking at this Q1 and Q3. It is not looking at the extreme ends. Okay, it is not looking at the extreme ends. So that way, IQR is comparatively, easier to also calculate. It may take a little bit of a thing to do, but it is comparatively easier. Okay, so interquartile range is another way, another standard deviation kind of a metric. Okay, another standard deviation metric. Now you may have a question, which one do we use, right? So generally standard deviation is the norm that people will use. Sometimes you can use interquartile range. When you are interested only in the centermost data, you can use that. Okay. So this is what is called your interquartile range. Okay. I hope now you have got an idea of how to interpret this table and you know now how it works, right? Okay. Yeah, sure, sure. What I'll do is, at the end of this session, I'll probably share this whole thing. It may be not so great in reading it quickly, but I think it can be used as a reference. Yeah, yeah. I'll probably share some instructions on how to open the data and all. Okay, we'll do that. Okay. Now, okay, see, till now what we have been doing is completely univariate analysis. Okay, univariate means you are analyzing one variable at a time. Okay. Now I'm going to talk about bivariate analysis. So what did we do? We spoke about univariate analysis and univariate. So we spoke about numeric and categorical. And in numeric, we like see now important thing is to know which kind of measures to use, right? So numeric, we know that we can use mean, median. 1 minute. So we can use mean, median, standard deviation, IQR, range, all these kind of numbers we can calculate, right? Similarly, when we come to categorical, we know that we can use counts, proportions, right? All these things. Yeah, kind of like variables like gender or ratings are all part of categorical variable. Now coming to discuss about bivariate analysis. What is bivariate analysis? Bivariate is nothing but analyzing two variables at a time. Okay. And what are we trying to do by analyzing two variables at a time is we are trying to see if there is any relationship between those two variables. Okay. So what kind of combinations are possible when you're doing bivariate? You can have one numeric variable and another one is also numeric variable. You can have one categorical variable, another one is also categorical variable. You can have one numeric variable and you can have one categorical variable. All combinations are possible, right? So now, how do we analyze these kind of combinations? So when you have numeric and numeric, you can make use of correlations. Okay, you can make use of correlations. When you have, see here, I'll show you all one by one. Okay, how to analyze it. Okay, we'll see that. So when you have categorical and categorical, you can use cross tabulation. Okay, cross tabulation. And when you have numeric and categorical, you can use aggregations. Okay. So numeric, correlations, categorical, cross tabulation, numeric, categorical, aggregations. Okay. So we can use this uh, different forms to analyze the variables. Let me show you what do we mean by all these things. Okay. Now let's say we are taking two variables. Let me show you the data once maybe. Did I load the data? I don't think so. Let me just load the data maybe once. Okay, bd dot get. Okay, so now if you see here, I'm taking the variable sales and I'm taking the variable comp price. What is this? This is the sales that is happening in that store and what is the competitor price in that location. Okay, they are having that two variables. And if you notice, both of them are numeric variables. Now I'm trying to analyze these two by using the correlation. So if you see here, I'm using the function called cor and I'm passing the two variables. See, first variable over here, dot cor, second variable. I'm getting a number called 0.06. Now, what is this number? So what are correlations? Correlations is a kind of a way to quantify the relationship between two variables. Okay, it is a way to quantify, matlab give a come up with a number which can tell how the two variables are related with each other. Okay, and this correlation, right, it lies between -1 to +1. Excellent. Okay, some of you have good idea about these things, right? That's good to know. So correlation lies between -1 to +1. Okay, so let me explain you a little bit on this. -1 minus 0.5, 0 plus 0.5 and 1. Okay. So if the correlation turns out to be close to 0, that means these two variables don't have any relation. I'll give you an example. Okay. Don't worry. I'll come to that. Let's understand how to interpret this and then I'll give you examples. So if you get a correlation which is close to 0, it means the variables don't have any relationship. If the relationship is positive, then it is called, yeah, R is one way to denote correlation. Okay, R. If the relationship is positive or the number that pops out for you is positive, that means it has positive correlation. Okay, it has positive correlation. Correct. Okay, and same way, if the value that gets computed and comes out is on the negative side, then it is called a negative correlation. Okay, negative correlation. Now, just because it is called negative correlation doesn't mean it is a bad thing. Okay, it is just that the relationship between those two variables is different. Now let's understand what is positive and negative correlation. See, when both the variables move in the same direction, it is called positive correlation. Okay, when both the variables move in the same direction, it is called positive correlation. When one variable moves in one direction and the other variable moves in the other direction, opposite direction, it is called negative correlation. Okay, let's take an example like for positive correlation. Your height and weight, right? As your height grows, your weight will also grow, right? Most of the cases, right? Some people may not put on that much weight, but if you see naturally, as your height grows, your weight also increases. You see both the variables, height and weight, they both are moving together. Height is increasing, weight is increasing. Height is increasing, weight is increasing. So they both are moving in the same direction. So it is called positive correlation. Okay. Now let's take another example. Let's say, for example, onion price is going up. Okay, onion price is going up. The number of kgs of onion you get will naturally come down. Do you see here now what is happening? The price of onion is going up. The number of kgs of onion you can buy is coming down. See, for example, earlier for 100 rupees, you could buy 10 kgs of onion. Now onion price has become 50 rupees. So what is happening? For the same 100 rupees, you are buying only 2 kgs. So what has happened? Price has also gone, price has gone up and your quantity has come down. So both are moving in opposite direction. Correct? So this is called negative correlation. When one variable is going in one direction, the other is going in the other direction, opposite direction, inverse relationship. Okay. So the purpose of using correlation is to see if two variables are highly correlated with each other or they have any relationship with each other. Okay. That means what, relationship with each other means, like for example, um, as I was telling, height and weight is a good example for you to understand, right? So as your height is increasing, your weight is also increasing. That means these two variables are related with each other. Okay, these two variables are related with each other. Another example is also probably your years of experience and your salary, right? If you see, as the years of experience increases, your salary will also slowly increase, right? So both of them are moving in the same direction. So that is again an example of positive correlation. But now the thing is, how do we quantify this, right? How do we get a number out of it so that I know how strongly correlated they are or how strong correlation they both have? That is where these numbers come into picture. Okay. So if the value is close to zero, that means no correlation. If the if the value comes between 0 to 0.5, it means moderate correlation. Okay, it has moderate correlation. If the value lies between 0.5 to 1, high correlation. Okay. And if it is on the positive side, you will say high positive correlation. If it is on the positive side, you will say moderate positive correlation. Okay. Same way over here, if it is on the negative side, 0 to minus 0.5, moderate. And here it is high. So what do we mean by high and moderate is, see, high means they both have really strong relationship. When one is going up, the other is also going up. Right? See, take for example the economy of a country. If the economy of the country is growing, the people's way of spending also grows, right? Because you are having more money at your disposal, so you're spending more, right? So both of them are moving. They both are highly correlated. Okay, highly correlated. I mean, they have very strong correlation between them. So the number, when you calculate and you get right, it will be somewhere between 0.5 and 1. High chance it may be around 0.8. Okay. At the same time, if there is a variable which is going, one is going up and other is going down. Like for example, let's say the temperatures and raincoat sales. Okay. The temperatures and raincoat sales. So what will happen over here? As the temperature goes up, naturally it's becoming summer, right? So the sales of your raincoats are coming down. So what is happening here? It's inverse. Okay. So then what will happen? Your correlation will become minus 0.7. something like that. Okay, so this is what is the relationship. Yes, car is traveling, so higher the speed, lower the mileage. That is a, it will be an example of which correlation? High speed, lesser mileage. As speed goes up, your mileage is coming down. Is it positive or negative correlation? Exactly. Okay, so it is negative correlation. Correct. Okay, guys. So I hope you understood what this positive and negative correlation is. And it is always bounded on -1 and +1. The number will not go beyond +1 and it won't go below -1. Yeah, so the bivariate thing over here I have written, right? Numeric, numeric, we make use of correlations. So we are discussing now correlation, right? Categorical, categorical, cross tabulation, numeric and categorical aggregations. Okay, let me go back now here. And there is this thing that you can generate a correlation matrix instead of doing one variable at a time, like, sales. Let's say I want to analyze sales and competitor price, income, advertising, population. I want to analyze all the correlations. So doing this may be kind of a task, right? To do that one by one. Instead, you can pass the whole data frame to it and just say bd.cor and it will give you a matrix. Now, how do you interpret this matrix? See here, just take this variable sales and look at like this. You see the numbers over here? See, the correlation between sales and competitor price is 0.06. What do you think? Is it no correlation, positive correlation, negative correlation, moderate positive, high positive? Correct? It is low correlation. It is very close to zero, right? So it is low positive correlation. It is, see the symbol over here, there's nothing, right? So it is positive. So low positive correlation. Okay. Now let's take, for example, what do you think is the relationship between price and competitor price? What is the relationship between price and competitor price? Correct? And what kind of relation? Is it positive or negative? High positive, correct. It's highly positive correlation. See, when I asked you about price and competitor price, see here there is competitor price. Here there is price. So the correlation is 0.58. And if you go back to our over here, 0.58 will lie somewhere here, right? So it means it is high correlation on the positive side. So high positive correlation. That means your price and competitor price are kind of moving in the same direction. Okay, so like you are increasing the price, your competitor is also increasing it. You are reducing the price, your competitor is also reducing it. So that kind of relationship is happening. Okay, now similarly, can you tell me what is the relationship between income and population, or let's say income and education? Okay, let's not take education. Won't make sense over here. Actually, education is a categorical variable. Let's take something else. Okay, let's take, for example, price and sales. What is the correlation between price and sales? Price and sales. Negative correlation, right? Kind of, it's in the, it's somewhere hanging between the moderate and low, right? It's actually kind of weak only, weak correlation we can say, or low correlation we can say. But you see here, what is the value? Price and sales, right? So you see it is negative. So what can we understand is, as your price is increasing, your sales will go down. If you decrease your price, your sales will go up. Okay, that is the relationship they both are having. Correct. But the relationship doesn't seem to be very strong. Okay, it seems to be having some relation, but it's kind of weak, not very strong. Okay, so this is the way where you can understand how, the relationship between variables exist by looking at correlation. But remember one thing, this is applicable only for numeric variables. Okay, only numeric variables. Okay. Next thing that we want to look at is uh, what did I take up here? Category. Okay, yeah, numeric and categorical. So numeric and categorical aggregations. So what is numeric and categorical is? See, one variable I'm taking is sales and categorical variable is shelf block. See, categorical variable, right? I'm trying to analyze these two variables now. Bivariate analysis, right? I'm trying. How do I do that? I have this function called group by. I pass the categorical variable here and I pass the numeric variable here. Okay, this may be slightly tricky, but again, I told, right, you need a little bit of in-depth analysis to be done, in-depth knowledge about programming to get to know more. But how does this work is, let me show you. It may look tricky in the beginning. So what we do is you take the data frame name, right? BD is the data frame name, right? This data is stored in something called as a data frame. So I'm doing this, and then there is a function called group by. Okay. In this group by, you need to use, it's a function, right? So use a normal bracket. And within quotes, I put the categorical variable name. Yes, Amran, you can use this on the cars data set also. The purpose is that only. You can use the exact things on your cars data also, but you need to use the variables which are relevant for that data. Here I am using the variables which are relevant for this data set. Okay. So when I use this categorical variable, I mean I won't get any output directly. I need one numeric variable. So I pass sales. Okay. And this you need to pass it in box bracket. Okay. As of now, don't bother. Just use it as it is. Okay. So that you get a hang of it. Okay. And then I'm saying dot describe. So what will happen? That describe function which we saw earlier will get applied here. So what are we getting to see over here is, see, these are all the categories of the variable shell block, right? Bad, good, and medium. And then here what we have are the numbers of, see these numbers that you see here, right? Okay, what happens when we don't put describe? Okay, see, when I don't put describe here, see, it comes like this. You won't get any output. Okay, so that's why you need the describe here. Okay, so when we put the describe, you will get an output like this. And what numbers you see here are nothing but the sales. Okay, the sales related numbers. See, this is very similar to your pivots. Okay, I'm sure you guys would have used Excel pivots, right? In Excel pivot, what you do, you drag the categorical variable, put it in your rows, and you put the numeric variable for the calculation, right? That is exactly what is happening here. So what I'm doing is, here what it is telling, see there are 96 rows of bad, 85 rows of good, and 219 rows of medium. And what you see here are the mean sales. Okay, these are the mean sales. What is shelf block? Shelf block is nothing but location in the shelf. Where are you keeping the car seat? Are you keeping it in a wrong place? I mean, bad location where people are not able to see it? Are you keeping it in a good location where people are able to see it? Or where are you keeping it in a medium location, meaning something where it is partially hidden? You cannot see it clearly. So what we can get to know from this is that, see, the sales are high when you have a good shelf location. See, when your shelf location is bad, you have a sales of average sales of 5.5, and when your shelf location is medium, you're having an average sales of 7.3. So having the proper shelf location where it is clearly visible helps you improve your sales. That is what we are able to understand by looking at this. Okay. Yeah. So this is how you need to see. No one told me this kind of information from this data. This is the kind of insights I have to generate from these data sets. Okay. So this is how you have to think analytically, and by using these techniques, right, of analyzing these variables, you need to find out. Okay. So what we are saying is that when you look at these over here, averages. Okay. See, I'll give you very easy way to understand also one simple thing. Okay. Let me take a simple example for you to understand this. Okay. Let's say there is variable called gender. Okay, and then there is a variable called income. Let's say gender is male, male, female. I'll put them together, okay, so that it is easy for me to calculate female, female, female. Okay, income is let's say 5,000, 10,000, and 20,000. Okay, and female, let's say I'm just making up the numbers. Okay, again 3,000, 5,000, and 6,000. Now, when we are doing that group by, right, what you're doing is basically you're taking this and this separately, male, female. And now you're calculating the average income, right? What is average income? Take the average of this. What will be 30, 35 divided by 3, right? Around 12,500 something, right? So 12.5K is the average income of male. Now here if I take 6 plus 5, 11, 11 plus 3, 14, 14 divided by 3, around 4.5K. So what we are getting to know is that the income of females is lower than the income of male. So clearly, wherever, let's say this is some organization or some company's data you have collected and you are analyzing that data and you find out these are the average incomes of male and female. I mean, you're looking at it by gender. You can clearly see that this company is being very partial. They are not paying proper salaries to the females because their salaries are comparatively lower than males. Okay, see, this is what exactly we are doing over here. Shell block is the categorical variable, sales is the numeric variable. So when we took that, automatically the code this did the same thing what we did over here. Okay, guys, now you understood this part of how it is working on the analysis of looking at this. Hmm? Yes, yes, you have to use group by. If you want to get the aggregation, you have to use group by. Remember, always use the categorical variable over here and the numerical variable here. Okay. Okay. Next, the third one is categorical and categorical. So we said cross tabulation. So what is categorical and categorical is you are taking two categorical variables. So for example, I'm taking shell block. What was the other one? Urban. Okay, so I'm taking shell block and urban. So if you see, this variable is also categorical. This variable is also categorical. So two categorical variables. How do I see what is the relationship or what kind of interpretation I can make? So what you can do is you can use something called as a cross tab. There is a function called cross tab. PD is the panda's name, then dot cross tab. And then you just pass the two variables. So when I do this is nothing but counts. Okay, this is nothing but counts. See, this is what, again, I'll try to give you a simpler example here. Let's say you have gender and smoking. Okay, male, male, female, female, male. Smoking, yes, yes, no, yes, no. What is cross tabulation? It is nothing but gender, smoking, male, female, yes, no. How many males are smoking over here? See here. Male, yes. Male, yes. So two people are smoking. How many males are not smoking? One person. Okay. So here. Okay. Now, how many females are smoking? One person is smoking. Okay. And how many females are not smoking? One person. Okay. So now if you see here, this is what is called cross tabulation. So we know that majority of the males are smoking here. Okay. So this is what. Okay, 1 minute, guys. Okay. So this is what I'll come to the question. Okay. We'll discuss it to open the cars in Jupyter. We'll get it back. We'll get back to that. Okay. Okay. Now, so now this is what here we have these two variables and what we are doing is we are trying to analyze them to see how the data is having the counts in this. Okay. So what we are doing is now we have the shell block and we have the urban yes, no. And here I've used an option called margins. Don't worry. Okay. These are all some options available in the Python programming. Okay. So you can use those. What it does is it adds the totals to the rows and columns. That's all. If I say margins equal to true, right? What will happen, in our case here? See, it will add total here and it will add total here. So basically 2 plus 1, 3, 1 plus 1, 2, 2 plus 1, 3, 1 plus 1, 2. So total is 5. Okay. So totally 5 rows are there, right? So it is showing the count. Perfect. Okay. So now what sometimes, looking at absolute numbers may not be so meaningful. It is always good to look at it from the proportions or percentages, right? See, if someone tells you, I got 10 marks, right? So 10 marks out of how much you don't know, right? To tell whether that person has done a good job or not. If 10 out of 10, excellent, you've done a good job, right? If it is 10 out of 100, you're not done a good job, correct? So just by looking at absolute numbers like this, sometimes it may not be very meaningful. So what people do is they look at percentages. So what you do is you take this number divided by the total number. You take this number divided by the total number. This number divided by the total. Okay, so if you write here false, right? See what will happen is, see these margins will not come. The margins will not be there. Margins meaning the totals will not appear. That's all. Okay, so now here what we see is the percentages. So you are saying that 5.5% of your data has shell block bad and it's not an urban location. So what we can analyze from this table is that uh, we can see that majority of the people, I mean majority of this car seats stores are having a medium kind of a view of the car seats. See, the data set is what? The data set is about sales of car seats. Okay, this data is about car seat sales. So what is happening is we are getting the store related information here, and it is telling in each store how much sales have happened, what is the competitor price in that location, what is the income of the people in that location, how much they are spending for advertising. Like that you have a lot of data. Okay, so now what we are looking at this over here, we are able to understand that majority of the people or majority of the stores which are in urban are having medium view. They're not able to see the car seat properly. That's why the sales are not happening well. So what they need to do is they need to improve that. These people, right, these stores, they need to improve the view of the car seats. They need to make it easily viewable for the customers. Right now, it is not so great. That's why the sales are not happening so well. Okay. So this is what is your interpretation for your cross tabulation between categorical and categorical. Okay. So this is how you need to analyze. See, when you're having two categorical variables, don't start calculating mean, median and all. It doesn't make sense. Okay. Always need to remember these three things. Whenever you're dealing with two numeric variables, do correlations. Understand the relationship. Whenever you are having categorical and categorical, do cross tabulations. Understand those relationships. Okay. And whenever you have numeric and categorical, you can do aggregations to see the relationship. See, what is the purpose of this analysis? For example, you are given a data and you are given whether it is gender. You're given a data of gender and smoking. You want to find out if gender has any correlation with smoking or let's say cancer. Okay. If you want to find out if there is any relationship between gender and cancer. So by doing such analysis, you will get an idea whether there is a relationship or not. If any of the percentages are high for a particular group, you know that male are having higher chance of cancer compared to female. Maybe because they are smoking more, they are drinking more, right? That's why because of that, chances of cancer are more. Okay. Okay. What is BD dot shape of 0? Okay. Yeah. These things, right? They may have a little bit of it. See, BD dot shape is what it gives me the number of rows and columns, right? If I want to extract only one of them, what I can do is I can just put a box bracket here and put 0. It will extract that 400 for me. If you want to extract that 11, right, I can put 1. Okay, and then you get 11. So this is for extracting the values from these things, okay, for usage purpose. I'm basically converting it into percentage here. So this is percentage. Okay, no problem. Okay, all right, guys. So I hope you got an idea of how to do bivariate analysis also, right? So I will now move on to visualization. Okay, see, till now what we have been doing is the summary statistics. Okay, we're looking with numbers. The same thing you can do visualization also and interpret them. Okay, it depends on what kind of work you're doing. Like for example, if you're doing the analysis for your own purpose, I think what we did over here in summary statistics is good enough. But now let's say you have to take the analysis and present it to your customer or to your manager or to your boss, then probably visualizations are much more intuitive. You can understand more by looking at a visualization than looking at numbers, and it looks very attractive also, right? Okay, so that's why visualization is also very critical in knowing about how to use it. He or she can analyze and run. Yes, yes. Anyone, I mean, see, pandas is the base package you have to know. If you know, then you will be able to analyze the data and come up with your interpretations. So you need to know a little bit of pandas. Okay, now coming to visualization, right? See, so visualization, right? There are again separate packages for visualization. Okay, so how we use pandas, right, for data analysis and all. There is another package called Seaborn. Okay, it's called Seaborn. Again, you have to install this package. Same thing, pip install Seaborn. Only one time job. Once you do it, you don't have to do it again and again. Next time you can just say import Seaborn. Again, I'm giving a short form as SNS. Don't ask me why are you giving SNS and why not SB or something else. It's just a way of people are used to those naming conventions, so we use it. If you want, you can give S also, or you can give SB also, whatever you want. There's nothing wrong in that, but then make sure that you use that short form everywhere. So now I'm using this, and I'm using the same car seats data set. Okay, so now, okay, let me first write this for you. Again, coming to visualization also, right? You have certain charts or graphs to be used for specific purpose. You cannot use any chart for any purpose. Okay, so each chart has to be used for a particular variable. Like for example, for numeric variable, again here I'll say univariate. Okay, again in visualization also you can have univariate and bivariate. So univariate numeric variables. Nandini, there is a question like is create another Jupyter. Do we have to install? No, no, no. So when you're creating new notebooks, right, you don't have to install. You just have to import. That's all. You don't have to install it again and again. Okay, fine, fine. I'll try to see. I don't recollect it. I'll just see. Okay, we'll take it up in the end. For the cars data, what are the categorical variables? Okay, we'll do that. So for numeric variables, we can have histograms. Okay, and wait, let me see what are the other things. Box plot. Okay, this part I think I'll. Okay, let's take up this also. Box plot. Okay, and for categorical variables, we have bar plots. Okay, so for numeric variables, we can use histograms or box plots, and for categorical variables, you can use bar plots. Okay, now what are histograms? See, histogram looks something like this. So you see this chart? This is called a histogram. So what is an histogram? Histogram is a way to show how your data is distributed. Distributed means where is the data sitting? Majority of your data, where it is sitting. See, let me take a very simple example and make you understand. Let's say I have a variable age. Okay, let's say we have uh, 25, 27, 29, 32, 30, 34, and 33. And then we have 38, 39, and then let's say we have 43. Okay, let's say we have data like this. What I will do is I'll create some bins. Okay, what I do is I'll create bins. So let's say one bin is 20 to 25, 26 to 30, 31 to 35, 36 to 40, 41 to 45. Okay. And now what I will do, I will count how many records are there in each of this. So between 20 to 25, how many numbers are there? Only one number is there here, right? So I'll put here one. Between 26 to 30, how many numbers are there? See here, 27, 29, two numbers are there. So I'll put two. Between 31 to 35, see here, 1, 2, 3. Three numbers are there. So I'll put here 3. Between 36 to 40, 1 and 2 numbers are there. So I'll put here 2. And again here there is one number. Now what I'll do is I'll plot a histogram. So histogram is nothing but, let's say here I'll put it as 0, 10, 50, or let's say 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay. So I put the age in the x-axis, and y-axis I'll put the counts. 1, 2, 3. Okay. These are the counts. Okay. So now what I will do is I will just draw bars. So between 20 to 25, I have 1. So I will draw this one bar like this. Okay. 26 to 30 is 2, right? So I'll just connect this and just touch it over here and draw this. And similarly, 31 to 35, I have 3, right? So I will draw this like this. And then 36 to 40, 2 are there. So I'll draw this. And then 41 to 45, 1 is there. So I'll draw like this. Don't mind my drawings. They are difficult for me to draw on the screen like that. But hopefully you got a hang of it. So what we see from this histogram is, you see that majority of the data is concentrated over here between 25 to 40 years age, right? You see the larger chunk of your data is sitting over there. So the histogram is telling you where your data is concentrated. So you know that your data is concentrated over here between 25 to 40 years of age. It's a visual representation of your data count. Okay, so same way, if I go back to my chart over here, you can see that, you see here, what did I do? I plotted sales. Okay, I plotted sales, and we use this function called dist plot. Okay, in Seaborn, yeah, in Seaborn, there is this function called dist plot. I'm passing sales to it. And you see here, this is the histogram. What I know is that the sales, no, between 3 to 11, majority of the sales are between 3 to 11. See, the majority of your data is sitting over here. And these are the counts. Okay. So what you get to know is where your data is sitting, concentrated, where it is sitting. That you get to know by looking at the histogram. Okay. Similarly, there is another one called box plot. This also can be used for numeric variable. This box plot gives you a summary statistic of your data. Okay. What do we mean by that is, I know this is a lot of information. Don't worry. It's a way to get an idea of what are the different things available. Okay. Okay, there is a question. Can we use matplot library? Yes, you can use matplot library. See, I told you all right. In Python, there is a problem of plenty. Okay, problem of plenty means same thing you can do in 100 ways. Okay, so whatever you are comfortable with, you can use those models and packages, everything. I'm using a Seaborn because it has a good visual appeal. Matplotlib is another library which you can also use. Okay, nothing wrong in that. Okay, fine. So now coming to box plot, right? Now, what is a box plot tell you is, see, a box plot looks like this. Any idea where you all have seen these box plots? Any place where you all have seen this? Anywhere you all have seen this box plots? Yes, share markets, right? Yeah, market trading and all. Most commonly you will see they are all, I think they indirectly, I mean another way of candlesticks and all also they call. Correct, correct, correct. Okay. So what does a box plot tell you is the box plot gives you a visual representation of your quantiles kind of a thing. Okay. See this line over here is your Q1, this one is your Q2 and this one is your Q3. So basically your 25th percentile, 50th percentile and 75th percentile. And this could be the max and the min. Different softwares give it in different ways, but let's stick to min and max. Okay. These are called whiskers. These are called whiskers. Okay. This is called lower whisker. This is called upper whisker. Okay. So now what does box plot tell us is box plot tells us kind of a summary statistics with a visualization. So can you tell me what is the median of this data of sales? It need not be exact. Roughly, what do you think is the median of the sales? Excellent, excellent, right? See this line over here that you see, where is it touching over here? Somewhere around 7.8 or close to 8, right? So the median sales is 8. Okay, the median sales is 8. And 25th percentile is somewhere here, right? See, this is the 25th percentile, somewhere around 5.7, 5.8. Yeah, right? 5.7, 5.8 it will be. And what is the lower whisker? What is the minimum value in this? Excellent. It is 0, right? Okay. So that is the how you interpret this box plot. So by looking at the visualization, you get an idea of your minimum, maximum, Q1, Q2, Q3. See, again, I'm telling you, this need not be the minimum and maximum always. Each software has its own way of doing it. Okay. So don't worry about that. As of now, you consider this as minimum and maximum. Yes, upper whisker is around 15. Okay, so this is how you can interpret. Yeah, so these two dots over here that you see are outliers. Okay, it is telling there are two data points which are above your 15. Some data points are on the upper side. These are outliers. So box plot can also help you identify outliers. Okay. Okay. Now coming to categorical variable, right? So when you have a categorical variable, as I was telling, we can use bar plots. So what is bar plot? Bar plot is nothing but, see, simple like this, counts. Okay. So what you are doing, there is a variable called shell block. Shell block has three categories, bad, good and medium. So you're just plotting that and you get the counts. See how many bad are there? Almost around 100 are bad. How many good are there? Something around 97 maybe. How many medium are there? About 200. Okay, so just by looking at the chart, you can understand for categorical variable. This violin plot I will skip. Okay, as of now it's not this thing, but you guys can read through a little bit more. It looks something like this. Okay, I would like you guys to do it as a home. Actually, let's make this part of your assignment. Okay, I want you all to read about violin plot and write the interpretation for that violin plot. Okay, so this is another plot called violin plot. You all can try to show that. Okay. Yeah, yeah, I will share this file with you all. Okay, I'll share this file with you all. Okay, I'll do that. Okay, now coming to bivariate analysis. Okay, so again, like how we had univariate in summary in for measures, right? No, Amlan. Bivariate is for sorry, violin plot is for numeric variable. Okay, it's for numeric variable. Okay, now coming to visualization for bivariate, right? Bivariate visualization. Yes, yes, you can do it in Google Colab as well. Okay. So we have numeric, uh, right? Numeric, categorical. Yeah. Numeric, and then categorical, and numeric categorical. Okay. So for numeric and numeric, we use one visualization called as scatter plot. Okay, this is something called as scatter plot. For categorical and categorical, we can use side by side bar plot. I'll show you what are these. Okay, side by side bar plot. And for numeric and categorical, we can use again box plot. Okay, don't get confused. We can use box plot for a single numeric variable also. And you can use the box plot for numeric and categorical also, bivariate analysis when you're doing visualization. Let me show you how it works. So now bivariate analysis, when you have sales and advertising I'm doing. Okay, we are using something called as joint plot. So what does this joint plot do? It creates something, this is called a scatter plot also. The name of that function, they call it as joint plot, but it is a scatter plot. So what is this scatter plot, It is nothing but, yeah, Seaborn has a good visual appeal. So that's why, people prefer using Seaborn. Yeah. I'll just zoom out a little bit, okay, so that you can see the chart properly. So you see this chart over here, right? This is called a scatter plot. Now, what is scatter plot? If I have to just make it easy for you, all right? Let's say age is there and income is there, okay? Age is 28 years old, income is 10,000. Age is 32 years old, income is 15,000. Age is 37 years old, income is 18,000. Like this, you have data, okay? How is scatter plot drawn is, it's very straightforward. Let's say you have age on your x-axis and income on your y-axis. So let's say age is like, 10, 15, or let's say 15, 20, 25, 30, 35, 40. Okay. Here it is, let's say 5K, 5,000, 10,000, 15,000, 20,000. Okay. Now what I will do, I'll take age 28 and 10,000. So age is 28 will be somewhere here and 10,000. I'll draw one dot here. Okay. Similarly, age is 32 and 15,000. 32 will be somewhere here and 15,000 is here. I'll draw a dot here. 37 and 18,000. Okay. So 37 is somewhere over here and 18,000 will be somewhere here. So I put the dot here. Like this, right? If you take all the data points and plot it, that is what is the scatter plot. Okay. So this is where what happens is scatter plot helps you understand. It's like, a visual representation of your correlation. So if the data points are all, see if the data points, let me draw one more visualization. Yes, scatter diagram, correct. See, if your data points are all scattered randomly, right, like this, that means there is no correlation. See, if I have to draw a line through this, the line will be flat, right? It is no correlation. Let's say if the data is like this. Okay, if the data is distributed, if you plot it is like this, and if you draw a line through it, the line is going slightly upward, right? So this means it is positive correlation. See what is happening here? As one number is increasing, the other is also increasing. Okay, so this is positive correlation. If you see the data points having spread like this, right? If they are spread like this, right? Then your line will be coming downwards, right? So this is negative correlation because as one is increasing, the other is decreasing. So the scatter plot can also tell you the correlation. Just by looking at it, you can tell if the two variables are correlated. So for that, right, just to see the line, right, if you want, you can use this LM plot. So you see here now, what do you think is the correlation between sales and advertising? Do you think there is correlation? Is there any correlation? If there is, what is the correlation? Excellent, excellent. Okay. See, the line is going slightly upward, right? It is moving upward. So it is a positive correlation. Means what we are saying, sales and advertising are having some relation. That is, your sales increase if your advertising increases. If you reduce your advertising, your sales will also decrease. That is what we get to know by looking at the. Okay. Similarly, there is another one for now coming to categorical and categorical. I told you you can make use of side by side bar plot, right? So there is this function called count plot in Python. in the Seaborn package, there is this function called count plot. You can just pass your categorical variable and you can, okay, you can just pass your categorical variable and you can tell the second categorical variable in this parameter called hue. Okay, see two categorical variables I'm giving and it will plot like this. So now what do I understand? Yes, yes. Count plot is for bar graphs. Okay. But it can do side by side, two bar plots together also it can do. Like here, what it is telling, how is the urban divided in median? Correct. Okay. How is the urban population divided in the medium shell block? So you see majority of them are urban here compared to non-urban. Everywhere actually non-urban is comparatively low, urban is high. Okay, by looking at this, you can judge how is the data distributed in them. Okay, finally, we have the numeric and categorical where I told you all we can make use of box plot. Okay. Okay, so next one is numeric and categorical. So shell block is there and sales is there. See, shell block is a categorical variable and sales is a numeric variable. So for that, I'm using a box plot. So you see here, okay, can you guys come up with some insights from this? It's totally fine if you are wrong, okay? It's totally fine if you are not on the right answer. Just see if you can interpret this chart. See, you have the categories over here and you have the sales over here. Can you interpret this box plot? Excellent, excellent. I'm getting some good answers here. Outlier is there in medium. Correct. See, there are outliers in the medium category. Okay, shell block medium, there seem to be outliers. Others don't have. Median of sales is highest in good shell block. Exactly. See here. See, there are three lines over here, right? See, this is the median of bad, this is the median of good, and this is the median of medium. You see, the median of good is higher compared to these two. That clearly indicates that shell block goods sales is much better compared to medium and bad. Okay, excellent. This is what, see, now by looking at the visualization, I'm able to generate some insights. This is exactly what is expected out of you all. Okay, so I want you all to also analyze and come up with solution like this. Okay, guys, I hope you understood this part, right? Okay, all right, great. Perfect, perfect, perfect. Okay. Okay, now coming to some of you all have asked a question of cars data where there are categorical variables. I just realized one thing is that um, so what we can do one thing, not a problem. See, sometimes categorical variables can be hidden under numeric variable. Okay, so what happens is they may not be directly be shown as a categorical variable. See, for example, yeah, exactly. As a 0 or 1, right? So, for example, let's say if I have a variable called gender and I have male, male, female, female, sometimes they may also write this as male is 0 and female is 1. So, they may write like this. Correct. Okay. So, what happens is they may not directly be visible as categorical variables. But one way to find out is if there are unique set of numbers, variable. See, generally numeric variables will have infinite set of numbers, right? Correct? Whereas for a categorical variable, there will be unique set of numbers. Just maybe 3, 4, or maybe within 10, like that it will be. Those variables you can consider as categorical variables. So now, if I show you in the data set here, okay, what I mean by that is, see, one easy way for you all at this point is see here, there are so many numbers. This is high chance that it is numeric variable. This one, okay, see here, there are only three numbers. So you can kind of consider this as categorical variable. Okay, here now you see again there are so many numbers. Numeric variable. See here, numeric variable, numeric variable. Okay, this also numeric variables. Again, now if I come here, you see here categorical variable. You see here categorical variable. You see this one now? You want me to zoom in? Okay. Okay, so see here there are very limited set of numbers in this variable. So you can consider all of these as categorical variables. See here this one also limited 0, 1. Similarly here, see limited set of values. So all these kind of variables you can consider as categorical. All the others, right? These see they have a lot of numbers. These are numeric variables. Okay, guys, is that clear? Someone had this question of which one to consider as categorical and all. Okay, perfect. So you want to change it, you change it. No problem. For your purpose, right? You can change it. Um, okay, you can change it if you want. How to import the file in Jupyter Notebook? Yes. Okay, let me come back to that question. Okay, see what you need to do is you need to keep this CSV file, right? This cars file, right? In the same folder where you have started your Anaconda. Okay, wherever you're starting your Jupyter Notebook, keep it in that same folder. Okay, and then you just have to say in the code like this. You just have to say, let's say I'm saying data is equal to pd dot read underscore csv cars dot csv. Okay, and you can read that data. Okay, I think this is where I need that encoding. Can someone share that encoding part, please? Yes, thank you. Latin 1. Okay, you see, okay, guys. So I think this is not a problem. Okay, you can just include this if you are getting an issue. Just put this part and it should do the job. Okay, I'm putting this part again for all of you all. Okay, I'm just putting this to so that all of you all are able to use it. Okay, so just do this. And now if I see, right, data dot head, if I see this, see my data is here. Okay, my data is over here. Okay, perfect. All right. So I think Tanuja, I am done with my part of discussion. Do we want to take up any questions or anything next? Okay, I think the assignment part, right? Okay, assignment part. Let me tell you all a few suggestions over here. Okay, guys. So the expectation from you all is step by step what I'm going to tell you all, right? You all can follow that. What you all need to do is take this data, get it inside your Jupyter notebook and start analyzing it univariate and bivariate. What I need you all to do is use the describe function. For example, you are using this describe function right over here. Let's say I have over here. You can take a screenshot or copy this whole thing. Like for example, I'll take a, let's say, okay, I can just screenshot of this like this. Okay, the whole output you take a screenshot and paste it in your PPT. Okay, let's say I'm putting here and paste it in your PPT here and write your interpretation over here. Okay, like, you can write your interpretation. Okay, you can put it over here and write your interpretation. Like the mean and median of most variables. No, there seem to be no outliers. Sorry. There seem to be no outliers in the variables as there is not much of a difference between mean and median. Like this, right? I want you all to write your interpretation about this. Okay. I will share both the notebooks for your reference so that you can just, try to make use of that notebook. Okay. And similarly, like for example, you have a chart. So this chart, you put the chart, I mean, copy the chart, put it in the slide Write what is your interpretation about this chart, about the two variables that you are analyzing. Write interpretations of them. Yes, yes, like how much values you are getting, how do you interpret it? Write your interpretations about it. Yes, you can analyze mean, median, standard deviation, all these kind of metrics and write their interpretation. Just don't write about the numbers. You need to tell the story around it. Okay. See, remember guys, numbers are always fancy to see, but the story part matters more. People buy the story, not your numbers. Okay. So you need to write the story around those numbers. You need to make that story around it. Okay. So that is what you need to do. Regarding the installation process, don't have to show. Put a screenshot of what tool you have used. Like, if you have used VS Code, just put a screenshot of that in the slide. If you have used Jupyter Notebook, just put a screenshot of that. That should do that. Exactly. The storytelling part matters a lot. Okay. Yes. Try to put all the type of charts you're generating, right? I want you all to put all that. Yeah. And all the assignments, you can put it in one PPT. Should be good enough. Using Anaconda on mobile phone, I don't know how you will be able to analyze it. That is my concern. Okay, there's nothing wrong in using it, but how will you write your code? It is very inconvenient to use mobile for that. I would recommend you to use a desktop version of working for it. I will share the notebooks for you all. Okay, for your reference, I will share the notebooks with you all. Okay. All right. Okay. So okay, Tanuja, I think I'm good from my side. There's anything else you want to discuss, we can take it up.
Thank you so much, Karthik, for the wonderful session. Students, I hope you had a good time and I hope that the session was clear and understanding and you were able to build on what was needed and understood how to do visualization. So, like Karthik had shared, definitely start working on your final deliverables. We would be requesting all of you to submit the entire, basically the work you've done inside one PPT. So, what software have you used? Include a screenshot. What analysis did you do? The steps that Karthik had shared, include it in your presentation, and as well as the visualization that you have done, include the graphs and have a description of what they are, so that this presentation kind of summarizes in a very concise manner of what you've done so far. And we would love to know how well you've worked on it as well. So this would be your final assignment. And regarding the submission, regarding how to go forward, don't worry, we will be sharing a Google form with you today by today evening so that you can submit whatever is needed there. So this Google form will be requesting your learning plan certificate once more. So those of you who haven't uploaded, please upload it to this link as well as the final PPT. So don't rush in and try to finish the form today. Work on your presentation, work on your on compiling the work that you've done so far, and ensure that you submit the same by Jan 5th. Okay, I repeat, the deadline for what we require of you to submit your final deliverables is January 5th. All right, which is today's second. So you have third, you have fourth, and fifth by evening. We expect you all to submit your final PPT as well. Like I shared, the contents will include your first page, which is who you are, your name, your college name, the state that you're from, and the title of your internship, a basic front page, right? Then we expect you to have the assignment one, which was the Anaconda the application or whichever program, whichever software that you've used, if it is Google Colab, anything for the matter, what you've used, we want a screenshot of what you have used as your second slide, followed by which please have your analysis as well as the visualization that you have done. Um, Regarding the slide number, not going to specify it to stick to 5 or 6, but don't give us a 25, 26 long presentation because we will be reviewing them as well. So this was a brief regarding the assignments. If you have any more subject related doubts, this is the best time to ask your mentor, Mr. Karthik. Or if you have anything related to IBM Skills Build or anything that is other apart from the subject, you can ask us and we will get back to you. Maybe you can use the next 5-10 minutes to post your queries, or you can always WhatsApp us and we will get back to you within 1 or 2 days. Yes, Tanuja, over to you.
Thank you so much, and for taking care of that. I hope you all had a very wonderful session, and whatever questions, queries you had, I hope you were able to get your answers to them. So, as Anne mentioned, that you have already gotten your assignment 3, and the last date would be 5th of Jan. So, please make sure that you adhere to the timeline and the deadlines, as we will be closing the submissions on this very same day, and we would not be in a position to accept to provide for any extensions. So, yes, and I will just go through the chat box once so to see if we have any more queries so that we can get Mr. Karthik to answer them while he's here. And please, if you have any queries regarding how to do the assignment and if you had any issues while reading the data, please, it's the right time to ask your mentor right now. Okay, so a lot of people are asking number of slides in PPT. So it should not cross, it should not be like 20, 25, 30 slides. Make sure that you can sum up things within 12 to 15 slides or lesser than that. 12, let's keep it 12, 13 slides, not more than that. Okay. Somebody's asking, should we work on the cars data set for the final assignment? Karthik, can you answer to that?
Yes, yes. So it's the cars dataset is going to be the dataset on which you all will be doing your analysis and submitting them. So as I think mentioned, right, first slide you all keep the screenshot of
Yeah.
the tool of what you have used, okay, and then second onwards you can take up the assignment of this data, summary statistics, and then the visualization. The visualization part is the assignment for today. You know, this is part of this sessions today, visualization part.
Okay.
Yeah.
Um, yes, that was about it. If you have any more questions, we have last 2 minutes. Please feel free to ask.
Uh,
And do not forget, oh, sorry, you were saying something.
Yeah, Tanu, sorry, I just saw one question like regarding the
Please,
variables.
please.
I will share, I'll do one thing probably. I'll share the description about the variables also to you, Tanuja. Maybe you can send it across to them later.
Sure, sure.
Yeah.
Also, don't forget to fill in your attendance before you leave the Zoom call. And please kindly have a look at your WhatsApp groups because we've already shared the attendance form there. Could we get today's notebook for reference?
Yeah, Tanuja, I will share all those things with you. If you could probably share it with the
I will.
students, right? Yeah, I'll send it to your email. Yeah.
Sure, sure. So, as Karthik is mentioning, the things that you guys are asking about, the reference and other things that will be shared to you guys in your WhatsApp groups. So, please keep a lookout for your WhatsApp group. Also, if you are by chance not added to the WhatsApp group, you can message us, you can WhatsApp us, or you can even post your message here and we'll share the link to the WhatsApp group here. So that was about it. And I think we can close if we have no more queries.
Tanuja, just 1 second. Students, I see that you're getting confused with assignment 1, assignment 2, assignment 3. Please understand that why we say assignment 1, 2, and 3 is because it's the assignment for that particular master class. You've had 3 classes so far. So every class towards the end, our speaker, Mr. Karthik, has shared a task with you. The first was on downloading and and understanding what what you would be using, Anaconda, whichever application that you're using. The second was on on analysis has, and the third today was focusing purely on visualization. So, as a part of your last assignment, I repeat, we are only focusing on submitting a presentation which compiles all the work you've done. So there is no separate submission on one and two and three. Everything is getting compiled into one presentation, and that's going to be shared. Yes,
Yeah.
all assignments in one PPT. That's it. So you'll have a column to update your learning plan. And the next question is on your final PPT. So don't try to rush in and try to fill up the form today itself. Finish your work, finish your presentation, make a good presentation to compile the work you've done, and submit it by Jan 5th towards the evening by the end of the day so that we can review and we can start issuing your certificates as well, right? A detailed description will be shared on WhatsApp. Don't worry. We will list out what needs to be done. We'll also post a message on WhatsApp. So you'll also be getting that as well. Thank you. Thank you, Tanuja.
Thank you so much, Anne, for pitching in, and I hope a lot of your concerns were addressed with what Anne said. So all of your assignments will be combined into one PPT. Okay, and so I think we do not have any more questions. Somebody's asking, are these certificates shareable on LinkedIn? Yes, you can do that. You can, when you share these on LinkedIn, you can always tag us, CSR box. You can tag your mentor. You can tag us on LinkedIn. Okay, so let's close it for today. It was wonderful having you on. And thank you so much, Karthik, for this amazing session. I think students are all enthusiastic to complete their assignments. And we're really looking forward to your submissions. Thank you so much.
Thank you. Thank you very much. It was a pleasure
Thank you.
being part of this session. Thank you.
Yeah, thank you.